The question we are solving now belongs to test series 6. It is of control system subject. In specific, it belongs to Nyquist analysis. Please note that this is a linked answer question. As per the question, there is a unity negative feedback control system. It gives an output of y of t is equal to 2 times e power minus t sine of t for an impulse input. We need to find the Nyquist plot of the system as omega is varied from 0 plus to infinity plus. From the given data, we see that the impulse response of the system is 2 e power minus t sine of t. This is the impulse response of closed loop control system. From this, we can say that the overall transfer function T of s is equal to Laplace transform of y of t, which can be written as 2 times s plus 1 divided by 2 divided by s plus 1 whole square plus 1, that is equal to 2 by s square plus 2s plus 2. But it is given that the system is unity negative feedback system, so h of s is equal to 1. That implies T of s is equal to g of s divided by 1 plus g of s, where g of s is the forward path transfer function, can be written as 2 by s square plus 2s plus 2. From this we can say that g of s is equal to 2 divided by s into s plus 2 is the forward path transfer function of the control system. From this, the open loop transfer function g of s multiplied by h of s is equal to 2 by s multiplied by s plus 2. We know that as a part of this question, we need to get the Nyquist plot as omega is varied from 0 to infinity. So let us substitute s is equal to j omega to get g of j omega multiplied by h of j omega is equal to 2 by j omega multiplied by j omega plus 2. This can further be simplified as minus 2j multiplied by 2 minus j omega divided by omega multiplied by 4 plus omega square. This is upon multiplying and dividing by 2 minus j omega. This can further be simplified as minus 2 omega plus minus 4j divided by omega multiplied by 4 plus omega square. And in g of j omega multiplied by h of j omega, we got, upon substituting omega equal to 0 plus, we see that g of j omega multiplied by h of j omega is equal to 0.5 minus 0.5 minus j infinity. Upon substituting omega equal to infinity plus, we see that g of j omega h of j omega is equal to minus 0 minus j 0. Also we see that from the given data, the Nyquist plot g of j omega h of j omega in the range of omega equal to 0 plus to infinity plus intersects with both real and imaginary axis as omega tends to infinity. From this we see that the Nyquist plot of the control system can be plotted as omega is varied from 0 plus to infinity plus as shown. At omega equal to 0 plus, the Nyquist plot has minus 0.5 minus j infinity, and as omega, so we see that the starting point is at a distance of 0.5 from imaginary axis, and as omega tends to infinity, the Nyquist plot intersects with the origin, that is it intersects with both real and imaginary axis. So the Nyquist plot of the given control system as omega is varied from 0 plus to infinity plus can be plotted as shown. From this we see that the correct option which represents a Nyquist plot of the given control system is B.